Hey everyone, Mr. Skelton here. We are back at it in our conic sections. This is going to be lesson 2. And we're going to be talking about circles. All about circles. Okay. So let's just jump right into it. I know this is a little bit smaller, but you can probably read it on your paper as well. But here's the definition of a circle. A circle is a set of all points in a plane that are the distance r, radius, from a given point, called the center. The distance r is the radius of the circle. Most of you already know that. This is common sense. If r is the radius of a circle with the center at the origin, this is important, if the center is 0, 0, then the equation of all circles can be written in this form. This is a plus sign, okay? So it's more or less this. X squared plus y squared equals r squared. And really what this comes from, this is the distance formula, or you can think of it as Pythagorean theorem, right? If you had drawn my right triangle there, then I have my x, which moves left and right. I have my y, which are my vertical distances. X squared plus y squared would equal r squared. So the equation of a circle really comes from Pythagorean theorem, all right? And then you're going to see when this origin is not at 0, 0, you can use either Pythagorean theorem or the distance formula. We could have also used the distance formula right here because this point would be x, y. This is 0, 0. I don't want to get too far ahead of myself, but if this is 0, 0 and that's any point x, y, I could use the distance formula here, right? X minus 0 squared plus y minus 0 squared equals the radius, right? And so that's the distance formula there, and that would just be x squared plus y squared equals r, and that's square rooted, so we would square both sides to get x squared plus y squared equals r squared. So I wanted to derive for you or show you how this is the equation of a circle. I did it with Pythagorean theorem, and I did it with the distance formula. Okay, so just to kind of give you some background of where that equation comes from. All right, so if you have a situation where, if you can read, not every circle has its center at the origin. You can use the distance formula, which I just kind of showed you, to find the equation of a circle with a radius and a center at hk. We've dealt with hk before. So let x and y be any point on the circle, so that's this point right here. X, y, again, that's your vertical distance and horizontal distance. And the distance from h to k to x, y is the radius. So you have your distance formula here. I substituted my hk in for x1 and y1 and xy in for x2, y2, and you come up with this equation, and you can kind of see how I got that. And I'll write it out in pen if you can't read it, but it's basically r squared equals x minus h squared plus y minus k squared. That is the equation of a circle with the center not at the origin. Now, I want to give you a quick helpful hint here. If I gave you something like this, if I said, okay, 9 equals x minus 3 squared plus y plus 4 squared, and I said find the center. Remember, the center is hk. You got to think opposite, right? You got to think opposite here. And you've done this all year, really, when we've done any kind of translation. So what would the center of this circle be at? If this is the equation right here, what would the center be at? It'd be at positive 3, because that's the x, comma, since that's a plus 4, it would be negative 4. My radius, what would your radius be? If that's r squared, a lot of students mess this up. This is r squared, right? 9 is r squared, so what would we do to find the radius? Take the square root of that, and we get a radius of 3. So that's how you're going to look at these equations. You're going to be asked to write these equations. But again, I'm kind of deriving this equation for you here and then showing you how it will work, okay? This next slide is essentially exactly what I just did, though, with some numbers. And so the radius was 5. I put the center at 3, 4, which would be right here. Radius of, I could just draw a circle, and I know my 1, 2, 3, 4, 5. It's going to be somewhere like this. This is not the best diagram, okay? But I could, if my radius I know is 5, I would end up squaring it here. There's my h and my k. So here's my hk right here, h and k. That's why it's a -3 and a -4. X goes with your h, y y's goes with your k's. And again, I'm just emphasizing in these first slides the equation of a circle, okay, and how we get it. So let's do some problems to kind of get you up to speed of what you're going to be asked to do in class. There's some real basic ones that I'm actually not doing on this notes because they're so basic, and when I say that, I'm basically saying this. We have some problems that are like this problem that I kind of went through with you. Here's the equation, and a lot of times in the textbook they'll actually write this the other way around. They'll go x minus 3 squared plus y plus 4 squared equals 9. They usually write the equation part here, the h and the k, and then the radius is always on the right hand side. But I just wanted to make you aware of that. But just saying like, hey, identify this center. Oh, 3, negative 4. What's the radius? Square root of that, 3. Those are some basic type questions that you should know how to do just by knowing that equation. These are a little tougher. All right, so it says find the center. So HK, I always like to write this out, and the radius, which we know is r, of the circle with this equation. Answer is down here so we can check to see how we did when we get there. Now, this looks crazy, right? Well, we're going to do something that we did in the first lesson, which is we got to complete the square, right? So if you think about the equation of the circle, you can kind of see the x minus 3 squared, y plus 4 squared, how completing the square could come into play. Because remember, this is really x minus 3 times x minus 3, or it's a perfect square. So how are we going to do that here? Well, what we want to do is we want to put our x's together. We want to put our y's together. And we want to put our constants, which are just your numbers, on the other side. And then we'll 4 complete the square. Okay? So let's take a look. I got x squared and 2x together. So I'm going to go x squared plus 2x. I'm going to leave some space, right, to complete the square. Plus, I got my y squared plus 4y. I'm going to leave some space, equals 16. Now I have this plus 1 and plus 4, which would be plus 5 on this side, but I'm going to subtract it. So I'm going to subtract 5 there, which would be 11. So now let's complete the square. How do we do that? Well, half of b squared, right? We take our b value, we cut it half, and we square it. That's how we complete the square. So half of 2 is 1. 1 squared is 1. So if I add 1 there, I got to add 1 to the other side. Half of b squared for 4. Half of 4 is 2. 2 squared is 4. So I'm going to add 4 here. If I add 4, then I have to add 4 on this side. So then I rewrite this as x. Remember, it's always half of your b value plus 1, quantity squared, plus y, half your b value is 2, quantity squared, equals 16 minus 5 is 11. I have 11. That would be 12. 12 and 4 make 16. So the direction says find the center and radius of the circle of the equation. So here's the equation of my circle. That's the equation. Now I got to identify HK. Well, it's plus 1, so I know I'm going to have negative 1, comma, because it's opposite, and negative 2. That's my center. So that's my H and my K, or my center of the circle. My radius is not 16. That's the most common mistake. This is, remember, 16 is really r squared, so I'd square root it, and I'd have a radius of 4. So those are my two answers, and you can see I have that right there. Moving on to the second equation, equation that we have, same directions. Find the center, HK, and the radius, R, circle. Go ahead, hit pause. There may or may not be an error here. See what you can try on your own, see what you come up with. All right, so now you notice that the y's are first. It really doesn't matter. You can move things around as long as you keep the symbol with it. So for example, I'm going to go x squared plus 6x, leave a space, plus, it's always plus in the middle, y squared minus 4y, leave a space, equals negative 4. Now there were no constants over here, so there's nothing to move over just yet. Half of 6 is 3. 3 squared is 9, so if I add 9 there, I got to add 9 there. Half of negative 4 is negative 2, but negative 2 squared is positive 4, so I'd add 4 there. So I end up getting x plus 3. Remember, this number right here is always half of your b value squared, plus y. Half of your b value is a negative 2 squared, equals plus 4, negative 4 cancel out, and I get 9. So there is my finished equation of a circle, and my center My HK is going to be, my x value is plus 3, so I'm going to go negative 3 and positive 2 for my center. Remember, this is r squared, so my radius is 3, not 9. All right, and there's my answer there. Moving on, we got one more. Okay, so this one is a little bit different. It says write the equation of a circle with the center. This is my h, this is my k, and goes through the point 6, 1. So if you want to draw this out, you can. You don't have to. There's 3, 5. 6, 1 is actually off the page a little bit there. Okay, and we want to write the equation of this. Now, what do we have to do? That should be the first thing going through your head. Well, what do I do? Well, it says write the equation. Now you can see the answer right here. Write the equation. Well, if you see that, you know it has to be in this form, right? That's what it's got to look like. Okay? So then how do we get there? How do we get there? Well, let's take a look. I just need to find r. I already have hk, right? I have x minus, this is a 3, so negative 3 squared, plus y minus 5 squared equals r squared. So how do I do that? Well, I just got to find the distance between those 2 points. So what's the distance formula, right? I have x2 minus x1 quantity squared plus y2 minus y1 quantity squared. So distance is going to be, I can call this x1, y1, x2, y2, and just plug in my points. So the square root of x2 is going to be 6 minus 3 squared plus y2 is 1 minus 5 squared. So 6 minus 3 is 3. 3 squared is 9 plus, that's negative 4, right? Squared is 16. And so I get the distance is the square root of 25, so d equals 5. So my radius is 5. And I put that back into my equation, which is this. Remember, that's got to be r squared, so my radius of 5 gets squared. And there is my final answer right there. All right? So a little bit more basic than the parabolas. You're still completing the square, obviously, in questions 1 and 2. If you feel better about that after the parabolas unit or lesson, then this hopefully shouldn't feel too bad for you, okay? So again, remember the first few slides were just showing you how we get those equations of the circle, but you're going to have to do problems like 1 and 2 and maybe a couple other real basic ones. As always, if you have questions, always look forward to helping you in class. See you then.